Hello everyone, and welcome to this week's video for the 2020 Community Cloud Challenge, Science is Better Together. We're really excited for the challenge to start next week on July 15th. You can find all the details on our website, observer.globe.gov, including how to participate by learning about clouds, doing cloud-related activities and projects, taking observations and exploring data, and engaging with friends and family about clouds. But on to today's topic. Hi, my name is Kristen Weaver, and I'm the Deputy Coordinator for the Globe Observer Project. If you've used the Globe Observer app to make a cloud observation, you may have noticed that you can look up in the Clouds tool when a satellite is passing overhead. But why do we want you to take observations at the same time as a satellite overpass? How do those matches get made? And what does it really mean to match your ground data to satellite data anyway? Well, fortunately, some of my colleagues can help answer those questions. First up, Marilé Colón Robles and Tina Rogerson will give us some of the details about the process and why matching to satellites is important. And then Heather Mortimer will walk you through some of the data she has collected and how the observations matched up, or not.
Hello, my name is Marilé Colón Robles. I'm the project scientist for NASA Globe Clouds at NASA Langley Research Center in Hampton, Virginia. And I work in a team of researchers where we collect your observations, match them to satellite data, and then do research to better understand what's happening in our atmosphere. Now, your point of view is very different from a satellite's point of view, and that's what makes it so great. So if you were to look at my cloud right here, and you think of the satellite would look from the top looking down. So the satellite will see the top of the clouds, and depending on the thickness, or maybe if there's another cloud on top of it, it might not see all the clouds that are in the atmosphere. Now, from our point of view, we see from the bottom looking up. So we see the bottom of the clouds. And maybe we might miss those top clouds, but we definitely see those low clouds. So when we combine the satellite's point of view of looking at the top of the clouds and maybe being able to see the higher clouds better than the lower clouds, with our point of view or your point of view from the bottom up, looking at the bottom of the clouds and definitely seeing those lower clouds, that's when we have a complete story. Now, let's meet somebody in our team that is in charge of all those satellite matches, Mrs. Tina Rogerson.
Hi, I'm Tina, the data manager for NASA Globe Clouds. As the data manager, I'm responsible for managing cloud observation data received from the Globe program and matching cloud observations to satellite data. I work at NASA Langley Research Center in Hampton, Virginia for the Science Directorate, which studies our amazing planet Earth and allows me to have access to the satellite data used for matching cloud observations too. Here at NASA, we use a combination of satellites to help learn about our planet. The Globe cloud observations are matched to multiple geostationary satellites, Aqua, Terra, and Calypso. Satellites can orbit the Earth in many different ways. The satellites we use in the Globe program orbit the Earth's equator or go over the Earth's north and south poles. We use both of these for our satellite matching. Geosynchronous satellites orbit 36,000 kilometers over the equator and remain over a single spot and always view the same region. Geosatellites are parked in what is called a geostationary orbit. They orbit exactly over Earth's equator and make one orbit per day. Thus, since the Earth rotates once on its axis per day, the GO satellite seems to hover over the same spot on Earth all the time. Their main task is monitoring the weather, so they need to never take their eyes off any given location on the Earth, so they can monitor developing situations such as tropical storms, hurricanes, and all weather anomalies. Polar orbiting satellites fly several hundred kilometers over the Earth's surface with a rotation period of about 110 minutes. They fly a much lower altitude than geostationary satellites and are used for monitoring Earth because each day, as the Earth rotates below it, they cover the entire Earth's surface. As the data manager for Globe Clouds, it is my responsibility to match cloud observations from Globe to satellite data. Satellite data corresponds to a cloud observation location and that is within plus or 15 minutes of the time an observation was taken is considered a satellite match. When a cloud observer makes an observation that is matched to satellite data, they receive a personalized email from us here at NASA. The email contains a table that compares the ground-based cloud observation to what the satellite observed. Satellite match emails are usually sent 24 hours to 4 to 5 days after an observation is submitted to GLOW. It takes several days sometimes to process our satellite data, thus this is the reason for the delay. Cloud observations can be matched to multiple satellites, so you might receive more than one email from NASA for a given observation. These satellite matches help us here at NASA better understand the different types of clouds and their effects on the Earth's climate. Satellites can only capture a top-down view of the planet, while ground observers complement what the satellite cannot see. For example, cloud bases, cloud cover, and multiple satellite layers. By putting these two vantage points together, we get a much more complete picture of clouds in the atmosphere. Thank you so much for listening. Y'all have a good day.
Hey there, my name's Heather, and I started doing citizen science long before joining the Globe Observer team as a writer and designer. I believe art and science both involve observing things very, very closely and looking at them from different perspectives. That's why I really love getting satellite match emails, especially on a day like today. It has been raining all day, so I don't think I'm going to be able to get out and take a clouds observation. I haven't checked my emails recently, so maybe there's a satellite match email in there. Oh, great, here's one. I love getting satellite match emails because they allow me to see clouds from both above and below. Sometimes they match perfectly, and sometimes they don't. Take this one for example. My observation and the satellites are pretty much in agreement. Next, let's take a look at this one. Okay, so what I notice about this one is that both Aqua and Goes East reported low clouds, but I didn't see anything. I have two ideas about what might have happened here. First, I've been working from home, so I've also been taking observations from home. I love that my neighborhood is full of trees, but it doesn't make observing clouds very easy. So, my view might have been blocked. Let's take a look at the satellite data. Okay, it looks like the clouds are more concentrated towards the edges of the image. So they may have been blocked by my house and the trees. I also noticed that the clouds were transparent. So even if my view of them wasn't blocked, it still may have been difficult to see them. Another thing that can happen is that low clouds can block your view of high clouds. Likewise, when the satellite is looking down, high clouds can block its view of low clouds. Here's a good example. It looks like the low cumulus clouds were blocking my view of the mid-level clouds, which I also mistook for high-level clouds. Here's another interesting one. See? It's almost a perfect match, with one exception. I reported 2 spreading contrails, but contrails are so thin that they're kind of hard for satellites to pick up. Here's another pretty close match. I think this is a great example of the value of citizen science observations. The satellites both reported a lot of high-level clouds, which is what I saw too. But I was also able to name those high-level clouds. They're cirrus, cirrocumulus, spreading contrails, and non-spreading contrails. Humans can add a lot of information about cloud types. Sometimes we also just make mistakes. Going through my observations, I noticed that I'm pretty good at identifying cloud types and estimating the cloud coverage. But I struggle with differentiating between different levels. The great thing about analyzing your satellite matches is that it can give you a better idea of areas where you could use some practice. I've learned a lot more about clouds since then, so now I know that the halo around the sun should have been a dead giveaway that I was looking at cirrostratus, not altostratus.
Right! That's why you don't need to be a cloud expert to do observations.
Oh, hey Marley. I wanted to ask, are there other reasons why my observation might be different from the satellites?
Yeah, there's a lot of reasons. Let me give you this one example. These are called subvisible cirrus. They're very thin, and we can kind of tell them with our eyes, but it's really hard to be detected by certain instruments on board the satellites. This is where your observations make a difference and help us improve our observations from satellites of what's happening in our atmosphere. Now, another example is look at this dust storm as well. The only reason why we know there's a dust storm happening is because of the globe observer making the observation. Because if you notice, it's complete cloud cover. So the dust layer is below the clouds. So from the satellite's point of view, remember it looks from the top down, looking down, it only sees the clouds. But your perspective is looking from the bottom up. So you see the dust storm below the clouds. It's so cool.
That is so awesome. So next I'm wondering if we notice any of those differences, like the ones that you just talked about and some of the ones that I talked about earlier, what do we do with that information?
Great question. So when you receive your satellite match table that compares your observations to the satellite data, there is a comment box right at the bottom. So if you scroll to the bottom under the images you get from the satellites, that is the best way to give us more information about that day and what you've noticed in the satellite table. So make sure to put there the date, what you observed, and any extra information, and just click submit. And it gets back to the clouds team at NASA Langley Research Center.
That is so cool. Thanks so much, Marley.
It was awesome talking to you.
So there you have it. I hope you now have a better understanding of why we ask you to take observations at the same time as the satellite overpass, and what those match tables you get in your email really mean. Thanks for watching, and for joining our community of cloud observers. We'll see you next time. And remember, science is better together.